start video. Okay, this is our quiz review. It's going to be over 1, 1, 1, 2, 1, 3, and 1, 5. Everything that we've done the last few days. This first question, write the equation of a line through the points. All right, every time you see write the equation of the line, they mean in slope-intercept form. So, am I not? They're going to ask you for the equation of the line, and that we're going to write it in slope-intercept form. Now, you can put this into point-slope form and then move it around and to manipulate it to be y equals mx plus b, or you can just go right into y equals mx plus b. So what I'm going to do first is I'm going to find the slope between these 2 points. So I have the point negative 3, 2, and I have the point positive 3, 7. Everybody agree with me?
Yes.
So my slope, I'm going to do 7 minus 2 over 3 minus negative 3. So I end up with 5, 6. Agreed?
Yeah.
Okay. So if my slope is 5, 6, then I'm going to choose one of these points. It doesn't matter which one. I'm going to use 3 and 7 because they're both positive. And then I'm going to use the slope, and I'm going to solve for the b so I can figure out what the y-intercept is. So if I use the point 3, 7, so I'm going to say 7 equals, what did we say our slope was? 5, 6? So 5 over 6 times 3 plus b, right? We good? Okay. So here, 6 becomes a 2. This becomes a 1. So I have 7 equals 5 over 2 plus b. Agreed?
Yeah.
Okay, so I'm going to subtract 5 over 2 from both sides. And before I can get my answer of what b is, I have to change 7 into halves. So yes, if this is 7 over 1, it would be the same as 14 over 2. So then I have 14 minus 5 gives me 9 over 2. Agreed?
Yeah.
So when I write the equation...
But why did you use 7 and not 2?
Why did I use 7 and not 2? What do you mean?
Where it says 7 equals 5, 6.
Like here?
Yeah.
Okay, so I solved right here. I said 7 equals 5, 6 times 3 plus b. So when you multiply 5 over 6 times 3 over 1, this crosses out, becomes a 2. This crosses out, becomes a 1. So I'm left here with 5 halves.
Yeah, I know, but why did you use a 7?
Because I used this point. I plugged that in for my y and my x so I could find the intercept. You can pick, you pick one of those points. Either one will give you the same intercept.
Oh.
So now we write our equation of our line. It's y equals, my slope was 5, 6, x plus 9 over 2. Whoops. And that would be your answer. But you got to find the slope and the y-intercept before you can just give your answer. Now we look at the next question. A couple things we need to write down for ourselves. When I see the word parallel, what do I think about the slope?
Same slope.
Same slopes. What question?
I didn't have enough time to write it down.
Okay. When I think perpendicular, can you see, Deanna? When I think perpendicular, what do I think about slope? Opposite, reciprocal. Remember, guys, I'm going to post this video, and I'm going to post all the answers worked out. So.
Oh, I'm good.
Okay. I'll post everything, though, the video and the answers worked out, so you guys can see it. And then I have neither. So if I'm given 2 lines, I need to put them into slope-intercept form so I can compare the slopes themselves. So I'm going to rewrite this first line, 3x minus 2y equals negative 9. And I'm going to solve for y. So I'm going to subtract 3x from both sides. So I have negative 2y equals negative 3x minus 9, right? And then divide everything by negative 2. So this line is y equals 3 halves x plus 9 over 2. That's one of the lines. That's the top one. And then I'm going to do the same thing with the second one. I'm going to do it up here so you guys can see. 6x minus 4y equals 5. So subtract 6x from both sides. Negative 4y equals negative 6x plus 5. Divide everything by -4. And I get y equals 3 over 2x minus 5/4. Now, do the intercepts matter when I look at these two things?
No.
No, the only thing that matters is the slope. So let's compare the slopes. Here is the slope of one line. Here is the slope of the other line. What do you notice about those two numbers?
They're the same.
They are the same. So if we have same slopes, these are parallel lines. So tomorrow, if this was a free response question and it says parallel, perpendicular, neither, there is a lot of work that goes into it. If you just answer parallel and it happens to be right, but there's no work involved, I'm not giving you guys any credit. So please make sure you show your work. Does everybody understand that?
Yes. Yeah.
Okay. If for some reason we don't get through this whole...
on paper, like how are we sure?
All right, next question says, are these lines parallel, perpendicular, or neither? So this is where we just find the slope. So I'm going to find the slope of the first pair. I like to write them on top of each other so I can see it better. So -1, 2, and 3, 5. So I have 5 minus 2, 3 minus -1. Did I get my signs right and all that? 5 minus 2, 3. Okay, so
Yeah.
I have 3/4.
Yeah.
Okay.
Yeah.
My next point is 3, 5, and 8, 10. And I apologize if you had Miss Glick last year because her handwriting looks like she typed it on a computer and mine looks like my 3-year-old daughter wrote it. But
Isn't it 8, 10, and 4, 7?
yes, see, that's why I write them on top of each other. Thank you. See how easy it is to make silly mistakes, guys. Thank you, thank you, thank you. Okay, so it's 4, 7, and 8, 10, right? All right, so 10 minus 7, and then 8 minus 4. So I have 3 over 4. Well, what do you notice?
But they're both the same.
They're both the same. So what kind of lines are these?
Parallel.
If, just for instance, I got a slope of 5/4 and a slope of -5/4. What's my answer here?
Neither.
Neither. Good. If I get a slope of 2 and a slope of -1/2, what's my answer?
Perpendicular.
Perpendicular, okay? Just make sure you guys understand the difference. It has to be either exactly the same or exact opposite reciprocals. All right, now we're going to do domain, range, increase, decrease, all that stuff. You guys have gotten really good at this, so I'm so proud of y'all. But remember, domain is on the x-axis. So where furthest left does this thing start, and the furthest right, where does it end on the x-axis?
Starts at -3 on the x-axis.
Yep. And then what?
What do you mean, where does it end, the whole thing?
Yeah, like this.
One.
This is where it ends.
Okay.
Where does it end?
+1.
+1. So I have a parenthesis on -3 and a bracket on +1. Why is that?
Because there's an open circle where -3 is and a closed one where 1 is.
Perfect. Range is going to go from bottom, the lowest value, to top, the highest value. What's the lowest value?
-4.
-4. What's the highest value?
0.
Perfect. And I'm going to have a bracket on both of those because in both cases, the function exists there. So now when I talk about increase, decrease, and constants, I cross off, remember, I cross off everything on the on the y-axis. Yes, ma'am?
In mirrors, then both of the brackets should be parentheses, right?
If it was arrows, it would be -infinity to +infinity. And it would be, yes, a parenthesis. If you ever have infinity, it's always going to be a parenthesis. Yes.
Then
All right, so increase, decrease, constant, guys. I'm going to start here. I'm going to put my pencil, and I'm going to follow this to here. What did it do? What direction was I going as I was drawing that?
Decrease.
Decreasing. I'm decreasing from what on the x-axis to what on the x-axis?
-3 to -2.
-3 to -2. Fantastic. And now I'm going to come here and I do what?
Increase.
I'm increasing. I'm increasing from where to where?
A -2 to 0.
Yep, increase from -2 to 0. And then
0. You're decreasing.
decreasing again. Now I can write it here or I can write it next to. It doesn't matter, but I'm decreasing from where to where?
You're decreasing from 0 to 1.
0 to 1. Perfect. Good job. Very good job. Very good, very good, very good.
For these questions, the parentheses and the brackets don't matter, right?
For what?
It's not. Like for the 0, 1 when you do.
On increase, decrease, and constant, excuse me, always have parentheses because you can't increase and decrease simultaneously. So it'll never include. Anytime we do intervals of increase, decrease, and constant, it's always a parenthesis. Good question.
Okay, thank you.
Good question, yes. All right, let's do B. All right, let's do B, and then I might skip ahead to some other ones because I don't want to spend too much time on just these. So if I look at B, okay, B's a little different because we have arrows, and that's okay. So let's think about it. My domain, from negative infinity is over here, positive infinity is over here. If you guys notice, these arrows they go on forever and ever and ever. So my graph is going to continually get wider on both sides. So what's my domain?
Negative infinity to positive infinity.
Yep, negative infinity to positive infinity. So my range, as I do my range, I go from lowest to highest. So about, I know this goes a little bit below -2, but what is this about?
-2.
So we'll say -2, and it just, excuse me, keeps going up, 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 for what?
Forever.
Forever. That's how we say it keeps going up forever with our infinity sign. Now when we do our increase, decrease, and constant, we're going to cross off everything on the y-axis because it doesn't matter.
Miss Meadows,
Yes, ma'am.
if they weren't arrows, what would the domain be?
From, I don't know, like -2.5 to say +2.25, something like that.
Okay.
Yeah. Okay, so increase, decrease, constant. From the left-hand side over here.
Miss Meadows?
Uh-huh. Okay, so as we read from left to right, this function is decreasing. Way out here, I'm starting a decrease. Till I get to where on the x-axis?
From like, sorry.
You're fine.
-2 and,
So like from negative infinity to -1.5.
oh, sorry.
You see that? That's okay. That's okay. I see what you're seeing. And then from here, it's going up. So that's an increase. So we would say it's increasing from where on the x-axis to where on the x-axis? -1.5 to what? What's this?
1.5 to 3. No,
On the x-axis. X-axis, looking at 0. Always looking at x. Cross off those y's. And then I'm here, and I'm decreasing again. So we're decreasing from where to where? It's another decrease. I'm going to put it next to it here. So I'm decreasing from 0 to +1.5. And then I'm increasing again. So we're increasing from where on the x-axis? 1.5 to going on forever and ever and ever and ever and ever. We say to infinity. So you guys got to really pay attention if there's stopping and starting points of negative infinity, positive infinity. Now, when I post hold on one second. When I post the answers later, guys, the other graphs will be done for you, but I want to keep moving so we make sure that we hit everything. Deanna, what's up? Okay. All right, here we go. All right, we talk about piecewise. All right, here's our piecewise function. Again, both of these will be worked out. I'm going to do number 6 because it's a little harder, but you guys are going to be expected to be able to evaluate a piecewise function. So if you have to use a table of values or whatever, you have to use a table of values. You've got to make sure that you understand how to do that. But this first this first line that we're talking about, how do I erase that? Our first line here is y equals 0. So I'm going to just draw a line right through y equals 0. Now, what is the parameter that they gave me? I'm looking between what values on the x-axis?
-5 and -2.
Okay, so 1, 2, 3, 4. Here's -5. 1, 2. Here's -2. So I want the stuff that's in between this. What do I do with everything else?
Erase it.
I erase it. Okay, so I'm going to erase. And then let's look and see what kind of notation I need on the end of my little piece there. Why is that so small? What are my dots on the ends?
For where it's -5, it would be a closed dot.
Okay, -5 is a closed dot.
Would be open.
-2 is open, and it's open and closed because one has an equal to and one doesn't. So then my second, what shape is this second piece going to be?
Parabola.
It's a parabola.
Would it be like an upside down U, or would it be like going up?
It is going to be upside down because it's negative. So what I'm going to do real quick, look, I'm just going to plug in -1, 0, and 1. Just 3 little points. So if I plug in -1, I have -1 squared plus 4. So -1 plus 4 is +3, right? So when I plug in -1, I get 3. Now plug in 0, I get 4. And when I plug in +1, what do I get?
You get +1. You get negative.
You get 3.
+3 again, because it would be like this. So I get -1 plus 4, 3, okay? So I'm going to go over -1, +3, 1, 2, 3, put a little dot. 0, 4, put a little dot. 1, 3, put a little dot. And then I'm going to draw my parabola. And now I'm looking where? Where am I looking for this parabola?
-2 and 1.
-2, +1. So everything else here, I do what with?
You erase it.
Okay, that's the part that I want, and then I erase everything else. So this is going to go away.
Wait, what points did you put for the parabola?
I just used -1, 0, and 1. I plugged it in just to give like a basic shape of what it was going to look like.
So does the open circle become filled in now?
Yep, very good. Because it doesn't work on the pink, but it works on the blue. So then it'll end up naturally filling in. And then what's the end of the other one? It's going to be also filled in, right?
Yeah.
Okay, and then our last piece that we have to do is just a line. So my slope here is -1, and my y-intercept is at +3. So I'm going to go up to 3. 1, 2, 3. My slope is -1, so it's going to go like this, sloping downwards. And then I'm going to draw my dotted line. And I'm looking between what?
Between 2 and 5.
So between 2, 3, 4, 5, and 5. So I'm going to keep this and erase everywhere else.
Right, they're all in a circle.
And both at the 2 is open and the 5 is closed. So it looks like that. Okay.
The other points sometimes don't connect.
Yeah, sometimes they don't, and that's okay. All right, we're going to go through this rather quickly because it's factoring, and we need to make sure that we are on top of factoring. So when we're factoring, guys, find the zeros. Find the zeros, the roots, the solutions, the x-intercepts. They all mean the same thing. It means take your function, set it equal to 0, factor, and solve. So the first thing I do when I factor is to look for what?
Things you can like factor out.
Things
like
you can
X.
factor out. We're always going to look for GCF. Do you guys agree with me that every single term in here has at least one x? So I can pull that out, and I'm left with x squared minus 8x minus 9 equals 0. So now I have x, and I can break this down into two binomials. What times what gives me a negative 9 when I multiply, but a negative 8 when I add?
Negative 9, positive 1.
So x minus 9 and x plus 1. And now what do I do with each piece to find the zeros? I set each piece equal to what?
You set each piece equal to 0.
There you go. So if I solve this, I set each piece equal to 0, so x equals 0. Now I'm going to add 9 to both sides. So when I add 9 here, I get x equals positive 9, right? And then I'm going to subtract 1 from both sides, and I get x equals negative 1. And I think I told you guys this yesterday, but look, this is raised to the third power, right? So that's telling you right there how many zeros you're going to have. Some of you like to check. You are more than welcome to. If you take your x values that you get and you plug them back into your original equation, you can check and it'll work every time. So that's a good way to check if you wanted to. Now, if I go over here to the second one, this is a little bit different because my a term right here doesn't equal 1. So first look for your GCF. Okay, there's nothing we can take out. So that means I have to multiply 2 times negative 30. Well, 2 times negative 30 is negative 60. So I need factors of negative 60 that multiply to give me negative 60, but add to give me negative 7. Now, some of you are like, oh, there's so many factors. Some of you guys are really good at this and some of you aren't. So look, I'm just going to write the factors out. 1 and 60. 2 and 30, 3 and 20, right? 5 and what? 5 and 12? Yes?
Yeah.
6 and 10? We got, yeah? All right, so I'm looking, what combination there will give me a 7?
Negative 12 and positive 5.
Yeah, there we go. 5 and 12. If I multiply, I can get 60. If I add, I can get 7. I got to play with the signs, but we found the combo. So again, this is the way I factor when a is not 1. You guys can do it however your teacher taught you. But I do agree that it's going to be a negative 12 and a positive 5 because I want a negative 7 when I add. So negative 12 plus 5 gives me negative 7. Now what I do is I take the a term and I put it underneath both of the factors. Does negative 12 divide by 2 into a nice pretty whole number?
Yes.
Yes, so this becomes x minus 6. Does 5 divide by 2 into a pretty whole number? No. So this becomes 2x plus 5. And now you set each parenthesis equal to 0 and you solve. So x minus 6 equals 0. 2x plus 5 equals 0. So add 6 to both sides. X equals 6 minus 5 from both sides. 2x equals negative 5. Divide both sides by 2. And I get x equals negative 5 over 2. Those are my zeros, my solutions, my roots. Those all mean the same thing. Okay, look at C. I'm set it equal to 0. X over 9x squared minus 4 equals 0. Well, how do I solve this? What do I do to both sides?
You multiply by the 9x squared.
Multiply both sides by 9x squared minus 4. 9x squared minus 4. So that cancels out. So I get x equals 0. And you guys are like, what? I have to have done something wrong. No, you didn't. You're good. X equals 0.
Hold up.
Oh, got another one. I didn't see this one. Okay. Square root of 3x plus 2 equals 0. How do I get rid of a square root?
You square both sides.
Okay, we're going to square both sides. When I square a square root, it cancels out. So I'm left with 3x plus 2 equals 0 squared is 0. Solve. Minus 2 from both sides.
Just negative 2 over 3.
Yes, yes, yes. X equals negative 2 over 3. Good. This is the part I like. I love algebra. So much fun. Oh, these. How easy are these going to be? Yes, ma'am. You need it. Am I going too fast?
Yeah, a little fast.
All right, let's talk about odd, even, neither. Algebraically and graphically. We love these. All right, if it's odd or even or neither, let's remind ourselves, even, these are the things you should remember with even. I want you to remember same and symmetric to y, meaning the arrows have to go in the same direction. Odd, I want you to remember origin. Whoops, let me say, well, no, let me do this. Odd is opposite and origin, meaning the arrows go in opposite directions and goes through the origin. So let's look at A. First thing you look at the arrows. They're same direction or opposite direction?
Same.
Same, okay? So it might be even. Does y cut this in half evenly?
Yes.
So this is even. All right, let's look at the next one. Look at the arrows. What direction?
They're opposite direction.
Opposite. Okay, so this one might be odd. The other thing we got to check, does it go through the origin? So it's what?
It's odd.
It's odd. All right, look at the ends. Opposite or the same?
It's opposite.
They're opposite. Does it go through the origin?
No.
So this is neither or neither, however you say it. Okay, look at the ends here. Are they the same or different? Opposite.
Opposite.
Okay, so does it go through the origin?
No.
So it's neither.
So it's neither. Good. We like these.
It's odd.
Look at the arrows.
They're opposite.
Does it go through the origin?
Yes.
So it's good. Good job, guys. How are we feeling?
Good.
Okay. Good. All right.
And my brain is still starting.
It has to be either same direction and symmetric or opposite directions and through the origin. It can't, this is a combination of both. So that's why I put this one, or we put this one on there, just to, kind of make you think a little bit. But good, I'm glad that you saw that.
So that.
Go-
So then we only go by what the graph shows? Because I was looking at it like there's more boxes showing on the right than on the left. So like if the left continued, they would be going in the same direction, which is why I thought it was even.
No, you can only go by what is shown on the graph, the picture itself.
Okay.
Yeah.
Excuse me?
Yes. All right, let's do these last ones. Determine if the function is odd, even, or neither algebraically. Remember, write this down. Even is going to have what kind of an answer?
Same.
The same.
Numbers.
Odd is going to have what kind of answers?
Opposite sign.
There we go. So let's do this. You guys can pick any number you want. I'm going to do 2 and -2.
Let's just do 1.
No, it's got to be bigger than 1. You can't use 1. So I have 3 times 2 squared plus 8. And over here I have 3 times -2 squared plus 8. I suggest you always use parentheses. So I'm going to go through this quickly, guys, so we can get going. But this is 4. So 3 times 4 is 12. And 12 plus 8 is 20, correct?
Mm-hmm.
Okay, so over here, this is 4. 3 times 4 is 12. And 12 plus 8 is 20. The number itself doesn't matter. It's the relationship that the two have to each other. These are the same numbers, yes?
Yes.
So this is an even function. That's what I expect to see when you do your work. Show me everything. So on this next one, I'm going to use 3. We'll use 3 and -3.
Can we do it by substituting -x?
You absolutely can. Absolutely. If that makes more sense to you or you like to see that better, absolutely. Okay, so now I'm using 3. So 3 cubed. 3 times 3 is 9 times 3 is 27 minus 12. What's 27 minus 12?
15.
Okay. Now over here I have -3 cubed. That gives me -27 plus 12. What's -27 plus 12?
-15.
-15. What do you see with these two? What's the relationship?
Opposite
They're
signs.
opposite, so that means this is what kind of a function? An odd one.
Odd.
Yep. But yes, absolutely. If you want to use x and negative x, feel free. You'll get the same answer. Just to me, sometimes it's a little more difficult. All right. Let's use, we'll just use 2. I was going to get creative and use 5, but we'll just use 2 and negative 2. So I have 2 times 2 squared minus 2 minus 1. 2 times negative 2 squared minus negative 2 minus 1. I would always put in parentheses. So this becomes 4, and 4 times 2 is 8, minus 2 minus 1. 8 minus 2 is 6, minus 1 is 5. Agreed?
Yeah.
Okay. So I have negative 2 times negative 2 is 4. 4 times 2 is 8. Minus a negative gives me plus 2 minus 1. 8 plus 2 is 10, minus 1 is 9.
9.
What is the relationship between those two numbers?
Nothing.
Nothing, so this is neither. All right, over here, same thing. Let's use 3. 3 and negative 3. So I have 3, 1 minus 3 squared. And I have negative 3 times 1 minus negative 3 squared. Okay, so 3 times 1 minus 9, right? So I have 3 root 8, negative 8.
Yeah.
Okay, so here I have negative 3, and then I have 1 minus 8.
Plus, cause. Oh no, sorry, cause.
Got to square first.
Yeah, you gotta square first.
So this would be 9, this should be 8. Yeah, so I have negative 3, and then I have negative 8. All right, guys, let me do this one question. I just want to make sure you understand how to do B. And then, like I said, I'll finish this video. I'll do this average rate of change here. But if they ask for the average rate of change, remember, it's just kind of the same thing as saying slope, but you're just not using a line. If they ask for the average rate of change, but they don't give you a graph, but they'll give you 2 x values, this is what they're doing. They're saying plug in one of the x values into the equation, solve it, find y, and then do the same thing with the other to find the points. All right, you guys didn't see one of these yesterday, but you might on your quiz, so I just wanted to bring this to your attention. So I'm going to evaluate this where x is negative 1. So I'm going to say negative 1 squared minus 3 times negative 1 plus 2. You guys with me? Okay, so I have 1 plus 3 plus 2. 1 plus 3 is 4, and 4 plus 2 is 6. So when I plug in negative 1 to this equation, I get 6. Everybody got it? Now I'm going to do the exact same thing, but I'm going to evaluate where x is 4. So I'm going to say 4 squared minus 3 times 4 plus 2. So 4 squared is 16 minus 12 plus 2. 16 minus 12 is?
4.
And 4 plus 2 is?
2. I'm sorry, 6.
6.
6. Okay, so now we're going to do our average rate of change where we just use our slope formula. So I'm going to say 6 minus 6 over what?
So, isn't it just 0? Because the 6 is
Correct. 6 minus 6
0.
over 4 minus negative 1. So I get 0 over
Over 5.
5, which is?
0.
So the average rate of change here is 0. What does that mean? What does the function look like if at that interval if the average rate of change is 0?
Nothing.
Not nothing.
It's horizontal.
It's horizontal. It's constant there.
Oh.
That doesn't always happen, but I wanted you guys to see what happens when you don't have a graph. Like here, they give you the graph. They want another rate of change, so all you do is just take the points. That's the end of class. I made myself an alarm. 3, negative 1, and then 0, negative 4. So we would say negative 4 minus negative 1, right? And then I'd say 0 minus 3. So I would get negative 3 over negative 3, which gives me?
+1.
+1. That would be your average rate of change.